Hello everybody and welcome back. I hope you're as excited as I am. We're on question number 10, and that means it's the last question in part A on our 2004 grade 8 Gauss paper. Okay, so if we finish this off, if we've done everything right, we'll get 50 points in total, and that's a third of the way to the maximum score of 150. So let's hope we do well here. Two positive integers have a sum of 11. The greatest possible product of these two positive integers is... Okay, we have some possibilities here. 35 is the biggest. What strikes me as odd here is that usually they'll arrange it in biggest, sort of smallest to biggest to smallest, but for some reason 30 is tacked on after the 35 almost as though it's an afterthought. This doesn't actually affect anything. I think it's odd usually. I mean, if you look at the last question with the Lake Superior, they have the answers going from smallest to biggest. I don't know why the 30 is stuck there at the end. Oh well, nothing that we need to worry about ourselves. Let's not distract ourselves while we do the competition. 11 is such a small number. What I think is probably the fastest way to do this question is to just list out all the sets of two positive integers that have the sum of 11 and figure out their product and figure out which one's the biggest. Okay, so let's go over to our notepad and we'll make a little, not chart, I guess, but we can have, well, the lowest positive integer we can have is 1, and then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10. We couldn't have 11 because 11 would have to be 11 plus 0. So 1 plus 10 gives us 11, 2 plus 9, 3 plus 8, 4 plus 7, 5 plus 6, 6 plus 5, and actually we don't need the bottom half of this list because it's just going to be duplicates of the pairs that we have above. So we can just multiply and see which one of these has the highest product. 10, 18, well 18 was one of our possible answers, so I'm feeling good here. 24, 28, and finally 30, and 30 is in fact the biggest. Okay. It's not really a whole lot more to this question. If you know more math, there are other ways you can sort of visualize this question. If you knew some grade 10 math, you could sort of be envisioning a parabola, or you could be envisioning some rectangles with perimeter 22 and integer side lengths, and which has the biggest area. And so one way to view it is, well, squares amongst rectangles with fixed perimeter have the biggest area, so we want the most square-like. So we want the two integers that add up to 11, that form the length and width of our rectangle, to be as close as possible, and that would lead us to 5 times 6 as well. If you know things like the arithmetic mean, geometric mean inequality, that can sometimes help you a little bit too. But nothing you need to worry about. Certainly, we've got, there's only 5 possibilities. We quickly computed their answers, and what was the actual answer? What did we need to bubble in here? 30, so that's E, the one that they sort of tacked on at the end there. Okay. But that did it. We're done part A of the contest, and questions in part A are worth 5. So that's a total of 50 marks. The whole contest is 150. So we're a third of the way there, and we're feeling good. Okay? Now, hopefully, when you tried this contest, and please have tried this contest before you watch the video, hopefully when you tried it, you were getting questions left, right, and center. If you have trouble with a question, always, especially on the competition, remember you can leave some of the questions blank and still be rewarded with 2 marks. I like that Waterloo values being able to say, I don't know. It's something I try and work into quizzes that I make up when I'm teaching. Okay? But we're going to look forward. We're going to train our eyes on part B. And if you haven't tried it already, go ahead and try it. I'll be doing question 11 in the next video.